UV visible spectroscopy part 2 is the present video. And now you are familiar with me. I am Saurabh, and let's proceed right into the subject. Now, this video is actually dedicated to the laws of photochemistry, laws of absorption of radiation by certain material, by certain chemical species, and what are the laws that governs the absorption of electromagnetic radiation that we are going to see in this video. A very early law, just like we have some laws of thermodynamics, there is also the law of photochemistry. That is known as the Grothes-Dropper law. And that says that only that light which is absorbed by a system can cause a chemical change. केवल वही लाइट, वही ऊर्जा, वही प्रकाश जो अवशोषित होता है वही रासायनिक परिवर्तन के लिए जिम्मेदार है. ये बनी बनाई बात है. One photon can be absorbed by one molecule, so there could be 1:1 analogy. But only that light which is absorbed by a system can cause a chemical change. And what is the chemical change? When you are talking about UV visible energy, they are responsible for electronic transitions. In atoms, one electronic energy level to other, and when you talk about molecules, there are molecular orbitals, promotion of electron from bonding to anti-bonding or non-bonding, and so on. So this is the first law of photochemistry that is known as the Grothes-Dropper law. But the interesting law is something else. And before going to this, let us have some idea what would happen if light is incident upon a chemical species or a liquid. It can be a solid or a gas also. But generally when you talk about liquids, when light incident upon a species, it gets reflected, refracted, transmitted, scattered, or absorbed. So if you have a beaker that contains some chemical species, and if you incident some monochromatic light of intensity say I0, then a part of light might be absorbed and a part of light might be rejected or transmitted. Some part of light may be scattered at right angles, and a very small part of the energy can be reflected back. So there are many things that would happen, but mostly and most importantly, monochromatic light would be absorbed and the rest of the light would be released, that is called a transmitted light, and some of the light is going here and there. But roughly speaking, I0 minus IT must be equivalent to the I absorbed. मतलब जो हमने डाली लाइट है और जो बाहर निकल गई लाइट है, जो निर्गमित लाइट है, उन दोनों का अंतर ही अवशोषित लाइट प्रकाश की बराबर होना चाहिए. दिस इज द कोड अंडरस्टैंडिंग. हालांकि दूसरे प्रकाश का भी देयर इज some loss. So now we are going to talk about the Lambert-Beer law. That's a very popular law in photochemistry. जितने भी इंस्ट्रूमेंट्स हैं जो स्पेक्ट्रोफोटोमीटर हैं या कलरीमीटर्स हैं या इवन IR स्पेक्ट्रोफोटोमीटर्स हैं जिन पर एब्सॉर्प्शन ऑफ लाइट का मेजरमेंट कैलकुलेट करने का या ज्ञात करने का जिम्मा होता है, दे आर गवर्न्ड बाय द लैम्बर्ट-बियर लॉ. A very fundamental, very important law of photochemistry, which tells that the amount of light is influenced, the absorption, and the absorption of light is influenced by the amount of concentration or solid present in the solvent and the thickness of the medium. So there are two different things, but then we'll see one by one how it goes. So this law gives the probability or rate of absorption of light by medium. Actually there are two laws. दो नियम हैं जैसा मैंने आपसे कहा. पहला लैम्बर्ट ने दिया था और दूसरा बियर ने दिया था. And combinedly there is known as the Lambert-Beer law. And what does it mean? उसका मतलब क्या है थोड़ा सा अपन देखते हैं अपनी नेक्स्ट